coming up next. Stay tuned to learn more about the state of the art in blockchain and cryptocurrency technology. Reimagine 2020.
Hey everybody, and welcome back to another university segment of the Reimagine 2020 Virtual Blockchain Conference. I'm Ashlie Meredith, the head of education over at MouseBelt Blockchain Accelerator. And with me today is our CTO and co-founder at MouseBelt, Galen Danziger. Hi, Galen.
Oh, hey, Ashlie. Happy to be here.
And he's going to help me kind of dive into the tech a little bit with our very knowledgeable friend, Dr. Mo Sadoghi. He's assistant professor at UC Davis. Hi, Mo. How are you doing today?
Hi, how are you doing? It's a pleasure to be here as well.
Yeah, great. Thank you so much for joining us. So why don't we just start with a little get to know you, and keep in mind, we've got a lot of students tuning in, and something we've been asking all of the people we've been interviewing is, how did you get here? What was your career path like? And what, advice you have for people maybe thinking about getting into the blockchain industry?
So how I got here is a very interesting question. So I kind of take you back. For the last 10 years, I've been looking into transaction and looking at the basic problem of how do you execute transaction at a large scale at a cost-effective way. And I started at IBM Research, specifically looking at transaction processing at IBM TJ Watson. And we looked at the problem of traditionally you have your transactions on your operational data, and then you have your analytics and your data warehouse. And what happens if you really wanted to get to real-time analysis, there is always a gap between these two systems. So we looked at from ground up, how do you unify transactional and analytical system? It's also referred to as edge-top, hybrid transaction and analytical processing platform. So that's where I started looking from transaction, from ground up, every aspect, every layer of the stack, from recovering, from logging, from concurrency, from all aspects of all facets of transaction. And in the last few years, we have sort of said, well, what would be the next thing? Because one may say, well, your sort of the workhorse of transaction, it eventually becomes a utility, just the way the cloud and computing has turned into that utility model. So how do we expand? How do we expand the scope of doing transaction processing? And one interesting thing that we stumble upon is that, what if we look at secure transaction? What if we say, instead of I need to trust a central entity, a bank or a particular enterprise, what if we do this in a very democratic and decentralized way? And at the same time, the blockchain has been sort of in the background, has been especially centered around cryptocurrency, has been gaining attention. So then we said, well, there is this new approaching sort of area of blockchain. And well, this is also, if you look at enterprise transaction, not just necessarily crypto, but just looking at enterprise side, how do we revisit this? And this is where we entered what I refer to as secure transaction based on this democratic and decentralized computation model. And this is where we end on the blockchain space. So I started and I moved to Purdue University. I was there for a while. And then there we kind of looked at it as the initial step. But then when I joined UC Davis back in 2017, since then, my entire lab, Expo Lab, which currently have over 10 students, from undergraduate to graduate and postdoc, all of focus has been on blockchain transaction processing.
So Mo, what would you say to someone who maybe looks at you and is thinking, I want to be a researcher at a university in blockchain?
So if the person likes excitement and likes lots of ups and downs, as we see in the blockchain space, and it's fine with having the uncertainty of how the blockchain is going to unfold, then I think that's would be a very exciting area. And there's a lot of interesting challenges and opportunity that lies in this space. And I think both the industry now looking for folks who have expertise in this space, also from the university. I mean, even in my lab, actively when I'm offering the various different blockchain courses, is that I want to be able to get students into research. So if there is interest and if they find a faculty who works on the area, I think that would be a very easy match, as long as that enthusiasm is there.
And so speaking of ups and downs and your lab, I know that you work at Expo Lab, but you also have a project called Resilient DB. And in another interview that we did for Bitcoin Radio, you kind of told us the story of the name. Tell us a little bit more about your lab, Expo Lab, the Resilient DB project, and where the name came from.
Yeah, so again, the Resilient DB, sort of the vision was set in place about in 2018, early 2018. And since then, lots of ups and downs. So we had a lot of rejects, and there was a lot of pushback from academic side, and there was a lot of pushback from various community that we tried to push the boundary of the blockchain. Often people see, well, this is not a new problem. It's a problem that is just has a lot of hype and is a old age problem. And they kind of miss sort of the key ingredients that has revolved and revived this new field. So there's been a lot of rejection. I've sort of been working with the students. It's okay, you have to, if you believe in something, irrespective of what the outside says, you just go back in and then you push. You take whatever you can learn from those inputs, even if it's negative, then you push forward. And so we've been doing that for the last few years. And it creates that notion of a resiliency. And that was what we were building. We wanted to build a resilient system that can handle thought and can malicious behavior. And sure, in some of these review process, there are malicious behavior as well too. It's not just a lack of a knowledge. Sometimes maliciously things get blocked. So that name is that, well, we now have become a resilient group. Every students are developing their resiliency. What better name and calling it Resilient DB? So it kind of all came together.
Yeah, great lesson for students interested in getting into blockchain. If you believe in something, you've got to be resilient. So I know that you're working on a particular consensus model with your project. Most people tuning in will have heard of proof of work, proof of stake, but you're working on something, and I'll turn it over to Galen to ask some questions after you explain it a little bit, and he can help us make this understandable for everyone watching. But it's proof of execution, right?
Yes. So we looked at is that instead of doing a mining, instead of doing this very expensive computation, why don't we go back into a traditional model of voting? We mean you have in our democratic society, but this voting needs to be resilient to both malicious behavior and also needs to be resilient if there's failure in the way. For example, if I want to mail my vote, what if my message gets lost? Or what if my message gets delayed? Or what if somebody intercepts and try to change my vote? So the system needs to be able to handle these type of failure scenario. And so we looked at it as what we call, as you mentioned, the proof of execution, is that is an speculative way if every voter can independently do the work that they need to do in order to create their endorsement based on the local computation without being aware of what everyone else does, and do it in a speculative way. And it's in speculative in a sense that it doesn't need to kind of hear everybody else necessarily. And it may kind of be diverged from what everybody else see the state of the current world. So how do we do this in a speculative way? And the way you do it in speculatively, that means we're reducing communication. And so that's kind of where we started in this speculative voting. And then kind of expand that to kind of ask other interesting question is that, well, how do we do parallel voting? Can we try to, at the same time, look at different problems simultaneously, build the endorsement for it, and do have this consensus of n consensus at a time, as opposed to having a single, again, trying to improve the parallelism and the performance. And then we'll look at, well, what if the way we do this voting is we want to kind of look at the voting in different regions separately. So for example, within a different state, can each state individually do their local election, and then somehow the result gets aggregated in a consistent way. And so then how does that communication look like? How does that distribution of work looks like, especially with the topology and the network and all the physical perspective of that. Then we kind of again expand that, say, well, if we now have this kind of a topology and there are sort of these related, dependent, but still independently local election that is happening, how does two local election centers communicate with each other reliably the result that was acquired in one region to another? So look at that communication paradigm, that reliable communication paradigm, and what is the, again, lower bound, the minimum that we can, minimum number of messages, the minimum amount of bits that needs to be passed over the wire in order to do that reliably. And then we look at the probabilistic aspect of it. How do you do that probabilistically to further reduce the number of messages that people need to communicate with one another? And we also have been looking at what if not just we're doing local election on the same topic or on the same data, what if we can also partition our data across these different regions? And for example, perhaps UK data only needs to be in UK and only need to be kept in the UK, and the US data needs to only be kept in the US. And now in this environment that not every site has full access to the entire world state, how do you now ensure correctness, consistency, while you can actually perform this voting, this cross-site voting even faster? So that's as another area that we've been looking at. So I think from that starting point is looking at sort of just expanding the breadth of all possible voting, and all have this central piece is that we want the security, we want the democratic process, we want the decentralization, and we want to be able to do as fast as we can. In some of the results, we can scale to 4 continents, 6 countries, 50, 60, or even 100 nodes, and we still can maintain 300,000 transactions per second. And if you look at the initial Bitcoin with the mining, I mean, this started about 7 transactions per second. So with 300,000 transactions per second, I mean, we've come a long way. We started with about 100 or 200 transactions per second when we started in the January 2018. So it's been a continuous sort of progress, improvement, rethinking, and going back to the blackboard over and over again in order to so really push this line of work as far as we can.
So yeah, that's definitely a really cool concept, because we've seen a lot of blockchain solutions in the past that really don't have the transactional throughput of a traditional database or a lot of other distributed systems. Do you think that blockchains or distributed databases will decentralized databases like this will start to see more commercial use as they get a little bit more mature, as they get that transactional throughput that's closer to what you might see in one of those other systems?
Yeah, and that's, I think, sort of what is pushing us forward. We also have several partners, of course, in addition to with MouseBelt and on the education side of blockchain. We have other partners such as Radix, another UK blockchain company. So, and they do have customers and they see a lot of use cases. Of course, IBM is also another big player in this space, especially on the enterprise. And we're really talking about permission blockchain. We're not really focusing on necessarily on the coin, which it's an important element, but it's also complementary or orthogonal to just doing decentralization, the democratic process. So definitely there's a lot of interest. In fact, we also have sort of a blockchain company that I started, Mockup Blocks, 2 years ago too. And there we have a seed funding from DOE, Department of Energy, that we're looking at how do we utilize blockchain in a scientific environment where you actually run it on an HPC with fully capability of RDMA and more advanced hardware. So again, to further improve at least this local type of consensus on a fully connected network, and to reach that scale, and not just on the normal workload of retail and sales, or just traditional operational workload, but also looking at a scientific scientific workload, and also bringing collaboration and trust in the way you run experiments. You allow you to do reproducibility of the experiment, but do it at the scale and can have the fabric or a platform that can sustain the need of the scientists as well too. So we definitely, I think, seeing a lot of different areas. Again, IoT, I know MouseBelt have also been looking at the IoT space quite a bit as well too. So again, IoT and sensors, whether it's in farming or whether it's in agriculture or in dealing with a natural disaster. And I mean, the IoT space is also very interesting, is that you have all of these inputs coming from your sensor, they're unreliable. But if I want to do decision-making, if I want to do analytics over an unreliable hardware, how do I transform it to a reliable setting? So what is that abstraction? Well, we say this abstraction could be the blockchain as a middleware, as a service. So I think that's another area for, I think, industry. The final thing that I would say is that in terms of the way we're architecting software, and like we see now the push onto the cloud, the push into the utility in terms of the resources, but now we see a push into utility in terms of functions and sort of the small pieces of the software on the serverless or on the API or function as a service. That's another new paradigm shift that affects the entire industry of software, which of course goes over all across all different sectors. So now if we're looking at these serverless sort of paradigm, what they provide is that, well, you can run it and you can sort of have the elasticity and the pricing model, everything attached to it. But the question is, how do you now reliably run the servers? And how do you now eliminate the needs of you to trust necessarily the cloud provider that you're operating on? So can you provide a reliability and fault tolerant paradigm that you can support these function as a service or serverless computing in a fault tolerant manner? And that again will have an outreaching impact on the industry as well too.
So yeah, I think that serverless concept is especially interesting. There have been a bunch of serverless platforms. You've seen like Amazon Lambda functions, Google has one. Everyone's starting to launch these serverless platforms. Do you see them running just on a blockchain somewhere, just a public network, or some company's private like permission serverless framework that people just deploy these decentralized serverless functions to?
So right now, I think, it's a great point, but right now I think people are just understanding really what serverless is. Sure, I think it's getting a lot of traction, but now how do I build my software in this serverless compute model? And one limitation of serverless is that they also have limited or no sessions. There's no memory of this process. So there's no redundancy or there's no reliability whether make sure that the result that the particular API or particular function is producing is correct, but also there's no memory of it. And that's where sort of the fault tolerance that comes into play, so that I have redundancy on the computation, but I also remember the result. I also remember the session. I can reach a consensus. I can reach an agreement. That means I have redundancy, but I also remember the result of my consensus, sort of the chain or the blockchain aspect of it. So now those two come into the play. It really sort of, again, expand the use case of the serverless beyond just a simple function call that has no memory. And well, you have to also trust the correctness of that.
Okay, yeah, that's a very cool concept. So any of these products that you're working on, is your lab going to publish libraries or reference concepts for people to try out?
Yeah, so that's what we've been, so our sort of umbrella projects called ExpoDB, which we have dozens of concurrency, agreement, commitment, consensus. So that's a distributed database plus blockchain. We also have proof of work and the cryptocurrency in it too. So that's our sort of our flagship sort of internal project. But out of that, we've started creating open source, sort of a piece of it, which was the spin-off, the Resilient DB, which has a lot of those elements. It has the core of the consensus that we haven't included every consensus protocol we developed yet. We haven't pushed it there, so there will be a timeline for that. But the core consensus is there, and the core democratic process, the core distribution, decentralization, smart contracts, various off-chain, on-chain capability, and code generation, pre-compilation to even improve the smart contract execution, fully sort of dashboards. You can just from the web browser, you can deploy it in any region on any cloud and fully controlled by the dashboard. You don't even have to worry about the underlying system. And you can even design your deployment. Is that how many nodes it's going to be on? Where is it going to be? What is the architecture of every node? How many threads? How much resources? So fully customizable. So that's in the last. I think we started our release late last year, and so we have on the third release. So every few months we've been pushing out more functionality for the public and for the students. And this platform itself has been so far, I mean, on top of my head, I would say that at least maybe 150 to 200 students as course project have used it, especially mostly at the graduate level. So they've worked on this. So it has been an important educational tool till this point as well too. So it's not just a research tool, an industry prototype, but also an educational piece as well to allow students to really focus on understanding how do you architect a blockchain, what are the different pieces of it, how do you contribute to different pieces, and how to utilize and build application on top of it.
Oh, very cool. So I think right now it's interesting. You have a product that's sort of transitioning from academic to getting applications and things built on top of it. What have you noticed that you had to add as you started to get, I don't know if commercialized is the right word, but as you started to get like users on top of it instead of just a conceptual level?
Yeah, so far, I mean, most of the stuff is just the script. You just run things and you get some results. Sure, it's the actual thing is running, but it is at the evaluation stage. But the several things that has led to from the moment you get to the application and the usability space was one, the smart contract, the language of the smart contract. So we supported Go language, which seems to be fairly popular for the new generation of the programmers. And then we also provide sort of more traditional store procedure type of function, type of smart contracts. Further, I would say almost Turing complete as well. So similar that you find in other products as well too. So fully capable there. The other thing that we had to revisit in sort of the actual management of the chain. So we look at different technologies like LevelDB, SQLite, embedded form of database, or more powerful databases to just maintaining the chain. So that was another piece that we needed to bring in. And the final piece was how do you actually deploy and run this? And sure, and a graduate student, we've been working on it for 2 years and develop all the fancy scripts, and finally they memorize the sequence of 100 different things that they have to run to finally get the system going. Well, it's not really sustainable and it's not really usable. So again, having the online dashboard to not only deploy and initiate the blockchain just from a browser, but also have a full monitoring tool to see what is happening, whatever the region that is running, what is the throughput, what is the messages being sent. So all kind of metrics as a KPI to kind of tell you the health, the monitoring of the system as well. So those had been essential, and they weren't part of our research. We're not going to really write papers on those, but for us to be able to connect and to allow people to use it so we can get those type of new requirements or new limitation that the platform may face, that was essential. So, and we did actually spend most of this year just focusing on those 3 items from the perspective of development. And I would say, well, there was not a whole lot of, in developing those toolkit, well, there weren't a lot of research. It was something that was known, but it was a toolkit we need to develop in order to support the use of the system.
No, absolutely. So as you move into the more research direction and new concepts, what are you actively exploring most right now on the ExpoDB project? So
the one thing is one way of kind of going back to the speculative execution, the proof of execution I kind of mentioned, is that we started with a single voting. And a single voting, in other words, means there is a leader, there's an election commissioner, there's a coordinator that commissioned the successful execution of a single vote, a random vote. And then we kind of looked at it, well, what if we have multiple commissioners that allows you to do these parallel voting, and which is substantially becomes beneficial when you do that. And when you come to do this parallel voting, and since they're operating on the same data, so they're actually running a different transaction for the same database. It's not that they're just independent, they are operating on the same database. So there needs to be a coordination, there needs to be unification of their states, because they diverge and converge, diverge and converge. And so we'll look at the minimum amount of necessary work that requires for that divergence and convergence. So now the next thing we're going to say, well, instead of having multiple commissioner, why don't we sort of generalize this a little bit further, saying that we don't have any commissioner, or every node can be a commissioner. And how is that going to affect? It's completely really decentralizing it. So we're not even sort of the logical or elected individual to run the consensus, to run the voting, just eliminate that. And the challenge with electing a commissioner to run the voting is that, well, there needs to be an agreement for that person to get on that task, and anything goes wrong when that person becomes malicious, you have to go through a fairly sophisticated process to adjust and adapt and replace that person. And that person, if it's malicious, is trying to hide that they're malicious. And if you have multiple commissioners, now if some of these commissioners again are malicious and they're trying to collude with each other, the complexity or the attack space just really expands, and it just becomes harder and harder. So now, can we eliminate completely the need for that? And that will potentially try to reduce the internal complexity. So if you don't have to elect and you don't have to replace, then why don't you move on as if there are no commissioner? Sure, there might be a little bit more, few more extra step in your normal path of election that is going to happen, but at least you don't have to worry about if the commissioner is faulty. And you expect some of these will be faulty, and well, you kind of, in retrospect, you discover them. In retrospect, through that speculation, you discover it, and there will be a settlement period. Like, for example, you have today with Bitcoin, you have to create 6 blocks. There is a settlement period, or even your traditional stock market, there's a 2-3 day settlement period for every transaction to settle. And through the settlement, through the speculation, completely eliminate the need of commissioner into the mix. And then the other aspect is that, so that's one aspect. The other one is that, sure, we eliminate the commissioner, but if we keep expanding, and if you have thousands or 10,000 participants and an endorser in this election, then how do we scale to those numbers? And just the communication, simple communication, everybody becoming aware of everybody's states creates enormous and a quadratic to the number of people, the messages that needs to be sent back and forth. Now we started looking at probabilistic ground on that, is that can every person looking at probability, looking at samples or people in their neighborhood through the gossiping probabilistic method to try to reduce the necessity for communication and further scale in terms of the number of nodes. So one is to scale the number of transactions per second, one is to scale the number of endorser or the number of registered voter that can participate in this type of election.
Oh, very cool. And I noticed you mentioned dealing with problems about just a huge number of messages being passed and gossip. I've seen another MouseBelt partner, Hedera, has really spent a lot of time on that. Have you investigated their solutions at all as well?
So, yeah, we've been looking at many different, a lot of folks are looking at this problem, and one sort of a general toolkit that has been being adopted by Libro and many others is to use more sophisticated encryption or crypto toolkit, and in particular threshold signature, and which goes beyond your digital signatures and allows to essentially electing a person to aggregate everybody's message with this new signature, and then just on that person on behalf of everyone can reliably distribute that. So that really helps with linearizing that communication cost. But then the challenge is that these so you reduce your communication costs, but you substantially increase your computation costs because these signatures are much more difficult to compute. And also there are no military grade implementation, at least no military grade available implementation of these new toolkits. So everybody kind of simulates it. So we've been looking at that. We've been experimenting with that as well too. So that's one direction that one can perceive, is to add computation to reduce communication. And in a sense, even sort of your Bitcoin kind of does that too. You by solving that puzzle, in a sense, a lot of it computation, but also it does reduce the communication as well too in certain scenarios. So you see that kind of trend in the Bitcoin space as well too. So that's one definitely interesting area, but the other one is more probabilistic. The other one that I've actually been using and it's becoming very successful is that, what if we say coding techniques, so information theory, information dispersal, kind of completely going in a different direction. So that's another route that we're looking at as well. And one interesting result, a theoretical result we had in that space was that, what if not everybody's interested in doing consensus? So there's a lot of people that are involved in the consensus, but there are some entities that simply want to run analysis and they don't want to participate in the actual consensus. How do you inform them of how to do their analysis, whether through deep learning, machine learning, or any kind of analysis they wanted to run? And they developed this, what they call a delayed replication, that we refresh their state in constant time using information coding without them to be part of the consensus, without to have the quadratic complexity cost of the consensus, but they can actually see reliably the data with some gaps. So they may be a few rounds behind, but they actually, the data gets pushed to them. So the other form of the consensus is that you request or you pull, but this is a purely push-based platform, is that you push the coded data to these read-only entity, and once they observe enough push, they can actually construct the state reliably, irrespective of the Byzantine or crash failure. So that's another mode that we show that the actual communication is, will be dealing with linear communication size there as well too.
Oh yeah, that's a really cool method actually. Let's see. So I guess outside of the core of ExpoDB, are you working on any particular applications of this in your lab as well?
So this is, I think, where mostly the undergraduate student come, and I also did a lot of help that MouseBelt brought to organizing the undergraduate clubs. So there's been several projects, and to different degrees they're continuing. One was the sort of a plastic coin, is that creating a coin to help you to recycle material, and I had a prototype of the machine that you put it in, and the token itself. So that has been one direction. The other one was the Justice, is that the use of blockchain in the legal and in the litigation. So it allows the lawyer and the client to be able to keep track of what was said, how much money was transacted, and sort of all the legal aspect to bring that reliability and transparency to that process as well. So those has been two of the project. The other one we will look at is for IP management and so in general project management internally. So that's another project that, again, with several other students have taken off. We've been looking at also grid, and especially what happened with the fires in the last few years, and the faults of the companies behind these, is that bring more accountability to energy exchange, and also more accountability to anything that is done on the energy infrastructure. So if there was something that was flagged as need to be replacement, so can we actually make sure they are permanently recorded, and if there are some sensors or conditions that are being reported and perhaps people are not being flagged, can we have a self-auditable log, self-auditing on the ledger of these in the energy space?
Yeah, that's awesome. You know, I love that as a philosopher, talking about more of those the philosophy or the underpinnings of this technology, which allows for more collaboration and democracy and decentralization. For anyone tuning in, I definitely recommend checking out our presentation we did with Federico Viola from the Catholic University in Santa Fe, Argentina. We go into kind of 3 philosophical concepts around blockchain technology, including decentralization, disintermediation, and blockchain as a truth generating machine, not just a truth machine, but a reality generating machine. Super interesting convo there. If anyone's interested in hearing more philosophy talk, but we're here with Dr. Mo Sadoghi from UC Davis. And thank you so much for joining on with us. Thank you, Galen, for your insightful questions.
Thank you, everyone. Looking forward to the conference next week.
All right, and back to Reimagine 2020 Virtual Blockchain Conference.
Stay tuned to learn more about the state of blockchain education at major universities all around the world. Reimagine 2020.